Okay, so good evening, everyone. Okay, now, currently we are back to here again, and welcome everyone back to our stream. For those that have been with us for 3 days in a row, including today. And so today will be our third day of our event, and today the topics, another topics, the subjects that are going to be shared is the science mathematics as well as the accounting mathematics. So we're going to start with the science mathematics at right now, and followed by 8:45, we're going to have a Q&A session for science mathematics. And at 9 sharp, we're going to follow by accounting mathematics, and at 9:45, we continue with the Q&A session for accounting mathematics. But for today, actually, no matter you are a student from science stream or accounting stream, you can join both the sessions. Since the concept that we share are the same, the chapter that we discuss are the same as well. So it's actually we can use, I mean, like, no matter you're from science or accounting, you can join both, okay? So that means you can just join us from right now until 10 o'clock, okay? And just a briefing about the response that I've got from you all for physics, accounting, and also biology. I feel so glad, and I wish to send my appreciation to everyone since the feedback that I got was pretty good. The rating was good as well. And the only request that, I mean, like, the most requests are like asking us to do such event more frequently. Okay, we're going to work on this, but we'll try to work on this, but I can't assure everyone that we're going to do such thing again before PSPM1, because I mean, like, even our PAL leaders have to have their time to study as well. So we will consider it. It's a very good suggestion, and we'll also be very glad to have this kind of program again if we have time. Okay, so if we have such event again, we're going to do promotions, and you guys are going to get it from your friends, your executive committee of academics in your college. We also share the posters, the promotional messages to you all. Okay. Okay, so starting from now will be the science mathematics. So to make a brief introduction, today we're going to have Damia, Batrisyia, and also Lim, who are the heads of subjects for science mathematics in KMS. And they are going to be aided by Suzanne and also Heng, who will be the assistants for today. So this is Damia, Suzanne, Heng, and Lim. Okay, I think you guys can make a self-introduction about yourselves.
Hi, my name is Damia.
Hi, I'm Suzanne, and I'm one of the PAL leader for Maths.
Hello everyone, I'm Lim.
Hi, niece and nephew. I'm Heng.
Oh, niece and nephew. So I suppose Heng is Uncle Roger.
What?
Okay. So for now we're going to start with Damia. So the time and the stream is yours, Damia. Let's get kickstart.
Okay. So you guys can see the slide, right? So we're gonna discuss topic 9, chapter 9, differentiation. So let's get started. So the first one is how to differentiate AX. Remember, when X is at the power, as ni jada the power, kita kena automatic ada ln A. For differentiation, you guys memang kena salin balik soalan yang dia bagi. Contoh kalau kat sini dia bagi AX, you guys kena salin AX lah. Okay, so contoh je 5X. You guys kena salin balik 5X and then letak ln base dia. Contoh kat sini ln 5 lah. Okay. Kalau X tu dia replace dengan function, you guys kena buat benda yang sama. Salin balik soalan yang dia bagi, letak ln base, and then you guys kena tambah differentiate dia punya fx. Itu untuk function. Contoh 7 tu base dia, 5x minus 3 tu power tapi in function, right? So you guys kena, bila nak differentiate tu kena salin balik soalan, letak ln base, ln which is ln 7, and then differentiate dia punya function which is 5x minus 3, differentiate your function, you guys tahu lah basic, just tinggal 5 je lah. Okay, so you guys boleh letak sama ada nak letak 5 kat depan ke, lon 7 kat depan ke, no problem. Itu tak ada apa-apa kesan pun. Okay, contoh yang kedua, 3 power of 2x square plus 7x. Kalau power dia kat atas, automatic dia akan ada ln base. Salin balik yang sama, ln base dia ln 3, lepas tu differentiate dia punya fx, which is 2x square plus 7x. So, boleh letak kat mana-mana je. Ln 3 nak letak kat depan pun tak ada masalah. Okay. What if dia punya base is E? Kalau base E dia sama je, just buat macam biasa. Salin balik soalan, ln base dia, which is ln E. Tapi ln E is equal to 1. So, dia akan dapat EX. So, kita boleh buat conclusion. After differentiate EX, we akan dapat the same as the question, EX balik. Okay. Tapi itu untuk EX sahaja. Dia lain kalau dia bagi function. Okay, kita akan skip yang ni. Kalau base E tapi dia punya tu function, dia akan lain. So, kita kena buat macam satu-satu. Salin balik soalan yang dia bagi. Lepas tu, kita differentiate dia punya fx, which is set 2x minus 1. Kita boleh tulis macam ni juga. Tak ada masalah. Tapi this one is easier to differentiate lah. So, differentiate dia, power bawa lagi depan, power tolak 1. Differentiate dalam bracket, akan dapat ni. 1 over set 2x minus 1. Tulis balik. And then ln base. Tapi ln base tu akan jadi 1 sebab ln E is equal to 1. Boleh simplify equal to this. So, this is how you differentiate E with function, with power and function. And next, ln x. How to differentiate ln x? Ln x, dia akan, bila ln je, dia akan automatic jadi 1 over apa-apa yang sebelah ln. Okay? Tapi ini untuk x sahajalah. Tapi kalau dia bagi function, you guys sama je, 1 over apa-apa yang di sebelah ln. Tapi korang kena differentiate fx tu juga. Okay. Ni simplify dia. Boleh choose mana-mana. Nak buat asing boleh, nak letak sekali pun boleh. Okay, jom tengok contoh. For ln for x plus 3, first we kena buat 1 over function tu, which is 4x plus 3. And then differentiate dalam bracket tu, 4. Because boleh letak asing boleh letak terus campurkan dia pun tak apa. Okay, kalau dia bagi set, salin balik 1 over function tu. And then differentiate dia punya function. Jadikan dia set as power, lagi senang nak differentiate. Power bawa ke depan, power tolak 1. Dapat ni, salin balik. And then bila set dengan set 1 over 2 plus dengan 1 over 2, set tu akan hilang sebab jadi 1. So kita boleh buat macam tu. Okay, next. Basic trigonometric function. This one memang akan banyak masalah. First 3 ni dia tak bagi dekat dalam tu kalau tak silap, Masa.p.m, tapi the last 3 ni dia bagi. Ni nanti Lim akan explain how to hafal dia punya ni, how to ingat, remember the sequence and all. Lim ada tips. Okay. So benda ni korang, you guys memang kena tahulah. Sin x equal to cos, apa semua ni. Kalau tengok kan, sin tan dia positif. Dia punya dy dx dia tak ada negatif kan. Tapi bila 1 over dia akan ada negatif. Tapi kalau cos, dia awal-awal cos tu dah ada negatif, 1 over dia tak ada negatif. Dia macam terbalik tau. Okay. Tapi ni like simple kan, sin x lepas tu dapat macam tu je. What if dia bagi power? Okay, power ni tak ada apa-apa pun sebenarnya. Dia just because dy dx kan cot x ini macam biasa. And then power tu bawa pergi depan, power bawa tolak 1. Cot ni stay. Yang dekat dalam bracket ni, jangan tukar apa-apa daripada soalan. Yang dekat luar bracket ni, ini dy dx of cot x. In case kalau dekat sini dia kata sin pun, ini dy dx yang dalam bracket kat sini, lepas tu yang ni, and ni salin balik yang dalam bracket yang ni. Bracket dengan bracket jangan tukar. Luar bracket is dy dx dia. Okay. Kalau x tu dia tukar fx, you guys differentiate dia punya sin fx tu macam biasa. Tapi x ni akan jadi fx juga. And then kena differentiate dia fx. Okay. And then the last one dia gabung semua. Dia ada power and dia fx. So you guys kena differentiate cos fx. Ikut turutan pun tak apa. So differentiate dia punya cos fx. Lepas tu power salin balik dalam bracket. Power bawa di depan jadi base. And then power tolak 1. Differentiate balik fx. So that's all. Nanti my friends akan continue.
Hi everyone. It's my turn for 2 questions. I really hope that all of you can really pay attention of these 2 questions because quite tough. Yeah, I can say quite tough about this question. Okay. Now we start our question. Given y equals to alpha times e to the power of 2x plus beta times e to the power of negative 2x, where alpha and beta are constants, show that d2y over dx squared is equal to 4y. So how are we going to solve this? Okay, first you need to differentiate the whole equation first to get dy over dx. And we know that you must take attention about this. Alpha and beta are actually the constant. Okay, differentiate this. Okay, alpha is constant, so don't bother it. Differentiate e to the power of 2x. We'll get e to the power of 2x times 2x times 2. Sorry, this 2 is actually differentiate of this power. Same goes to this one, beta. Don't bother it. Leave it alone. And then rewrite it e to the power of negative 2x times negative 2, which is the differentiation of the power negative 2x. Rearrange the equation, we get 2 alpha times e to the power of 2x minus 2 beta e to the power of negative 2x. And then now we need to differentiate it again. Same goes. 2 alpha is the constant, so don't bother it. We differentiate the e to the power of 2x. We get e to the power of 2x times 2. Differentiate the power. And then minus 2 beta. Sorry, typo here. But just copy the differentiation. Copy the e to the power of negative 2x. Then differentiate the power. Become negative 2. Just do the normal calculation. We'll get 4 alpha times e to the power of 2x plus 4 beta times e to the power of negative 2x. And then now we take out the common factor, which is 4. And then we can actually see that this equation, right, is same like the y. So just sub the y inside here. We'll get d square y over dx square is equal to 4y. So we shown. Okay. Next. I hope that you can really pay attention about this question, especially the A part. Now you are given 2 parametric equation, which are x is equal to theta minus sine theta, and then y is equal to 1 minus cos theta. The question is asking, find the equation of the normal to the curve at a point with parameter pi over 2. What does this mean, like the normal to the curve? Okay, show this. This is the curve, right? But not really the equation lah about this x and y. Just the example here. Here is the tangent at this point. Maybe don't know what point. Either one point. Okay. This is the tangent gradient of this curve. Then the question is asking, find the equation for the normal. What is normal? Normal is 90 degree. Okay, 90 degree to the tangential gradient. Okay, let's see how to solve this question. To find the normal, right, you actually need to find the tangent gradient for this equation. Okay, let's work it. We know that the tangent gradient is actually dy over dx. So to find that, you need to differentiate dx over d theta first. Differentiate theta, we will get 1. Differentiate sine theta, we will get cos theta. I think this is simple. Okay, dy over d theta, 1 is constant. So differentiate, we get nothing, 0. Negative cos theta, we will get sine theta. So how we find dy over dx is actually dy over d theta times d theta over dx. Just sub the value inside, we get this. Normal calculation, we will get sine theta over 1 minus cos theta. Now we got the tangential gradient. We can find the normal gradient for this curve. The gradient for the normal curve, the gradient for the normal equation, right, is actually -1 over m. What is m? M is the dy dx, the tangential gradient. Start the value inside. Just flip it over. Get cos theta minus 1 over sine theta. If you think I am too fast, you can actually stop first and then screenshot the working. Okay. Then the curve at the point, right? We need to find the point with parameter pi over 2. So we sub inside the theta with pi over 2. Sub inside. This one, sub inside. Sine pi over 2 is actually 1. So pi over 2 minus 1, we get the x point, the coordinate of x. So the coordinate of y is 1 minus cos pi over 2. Sub inside the value, very simple. And then cos pi over 2 is equal to 0. So we get 1. Okay, this you need to pay attention. This is the gradient formula. We also learn in physics and also form 4, form 5, I'm not sure. Y minus y1 over x minus x1. This is the gradient formula. Okay, rearrange. We'll get y minus y1 is equal to m times x minus x1. Sub inside the value. Y is equal to 1. And then what is our m? The normal gradient. Sub inside x minus the x1. x1 is pi over 2 minus 1. Okay. Normal calculation, just sub inside the parameter to this theta, pi 2, cos pi 2, then sine pi 2. Just press your calculator, you will get this answer, and then this is actually the normal calculation. Okay, minus 1 and minus 1 can cancel it. We'll get y is equal to negative x plus pi over 2. Okay, I leave it for 1 second. You can take the screenshot for this working. Okay, next. Find the value of dy dx at the point with coordinate 1, 0, which lies on the curve, this equation. Okay. Obviously, the question is asking for dy dx, right? So we need to differentiate this equation. How are we going to differentiate this equation? We are using implicit differentiation and then the product rules. Let's see. This part, okay. This part is this part. This part is this part. Okay, and can see, right? EY, just copy. This is U, this is V. Just copy and then differentiate the U. We will get 1 because it's X. Then times, it's plus EY, copy. Oh, sorry, not copy, because the differentiate the EY, right? So we write the EY, and then since it is implicit differentiation, so we write the dy over dx, and then times, copy this again. This we no need to differentiate it, so become x, plus this another y times ln x. How to differentiate it? So just copy, okay, same goes u and v. This ln x, copy, and then differentiate the y. We'll get dy over dx plus, copy the u, this one is y here, and then differentiate ln x. We actually get 1 over x. 5 is a constant, so we get 0. Is that clear? Okay. We arrange the whole formula, the whole equations. With dy dx, we put at the left-hand side, and then another one, the rest one, we put at the right-hand side. Take out the common factor, we get the dy over dx here, and then times here. Okay. And then we throw this thing, this whole thing over this side. We'll get this equation. I think this is a normal calculation, not hard for you all, right? Then just start the value, coordinate is given here. So x is 1, y is 0. Just start inside all the value, press your calculator, you actually get this one, and then the final answer is dy over dx is equal to -1. Solve. That's all. That's all for my presentation. Thank you.
Before I start I believe most of us, when reading our question, right, we might have been through the situation that our mind just went blank, right? So some tips I can give for you guys is just not to be panicked, okay? Anything but not to be panicked. So the only thing we can do is to work on the information given from the question. So when you don't know how to start, where to start, you just take anything from the question given and just work with it. So in the meantime, your mind might develop some ideas from it, so you don't have to worry much, okay? So continue with our slide. So the question given are a curve. So and a and b are constant, which mean a value of numbers, and our x and y point are given too. So it is given dy dx equals to 1, and we have to determine the values of a and b. Okay, so as I said just now, we just take anything from the question. So we copy back the equation, and then we can sub the value of x and y into the equation. So it's just a normal calculation. So we will get the first equation, which is a plus 2b equals to -5. Okay, so how do we get second equation? So as I said again, we take everything from the question given. So it's given dy dx equals to 1. So we have to to x squared, we make our first derivative, we can get 2x. So since it is an implicit function, so whenever we derive something with y, we have to add dy dx behind of them. So we just continue it with our normal calculation with first derivative. So we will get our second equation is -a plus b equals to -10. So what do we do with two of these equations? So simultaneous equation come to our mind, right? So we can just plus both of the equations together. So we will get the value of b is equal to -5, which is just normal calculation. And since we get the b value already, so we have to get a value, right? So we just sub the value of b equals to -5 into equation 1. So let's proceed with another question. So it's given y equals to x ln 3 to the power of x, and we have to show that this equation is equals to 0. So the first thing we have to get is our first derivative and then second derivative, so that we can sub everything to this equation to prove that it is 0. So for the information given, we just take it, and y equals to x ln 3 to the power of x. So as ln, we can just proceed it with just using logarithm rules. So we bring down the x, and x times x we get x squared ln 3. So it's easier for us to make our first derivative. So we get our dy dx is equals to 2x. Since ln 3 is just the value of number is not unknown, so we can just ignore them and continue with the so we just ignore it, and then we differentiate 2x, we get 2. So we just sub everything into this equation. So we get 4 dy dx. We start with 2x ln 3 minus 2x. Second derivative, sub it into the equation also. So we get minus 4. We don't have to do anything with the y or the x. So we just sub the y with the equation given in the question, which is x squared ln 3, which we have derived it already. So at last simple calculation, we will prove that the whole equation is equal to 0. So shown. Okay, so if when we're solving this kind of shown or proved question, right, if we didn't get the answer given in the question, which simply means obviously that we are wrong, right? So it is a chance for us to redo for it since we know the answer already. Okay, so for 2b, it is a parametric function, and it's given x equals to e to the power of 2t and y equals to 2t plus t squared. So Roman 1, we have to find dy dx and second derivative in terms of t. So how do we proceed with this question? Okay, so basically we just have to memorize the formula. So the formula is not, we have to memorize it for us to easier to work things out. And we just take x equals to e to the power of 2t. So first derivative dx dt equals to, so we just copy back e to the power of 2t and differentiate 2t, we get 2. So we just time the two of it together. So we get 2e to the power of 2t. And then we proceed with y equation, which we get dy dt equals to 2 plus 2t, which we derive from this. So to get our dy dx, we just have to sub both of this into this equation. So the formula is dy dx equals to dy dt divided by dx dt. So I put times at here, so we just terbalikkan the whole thing at here lah. So and then we just sub dx dt and dy dt into the equation. So we get dy dx equals to 1 plus t over e to the power of 2t. So for second derivative, it is another formula which we have to memorize it. So we have to differentiate dy dx, which we get from just now, and then divide by dx dt, which I inverse the thing as I put times in here. So this is the information we get just now. And then since it's 2 layer, right? So to derive 2 layers thing, we have to use quotient rule. But if you want to use product rule, it's also can lah. So just you use whatever you prefer and whatever is easier for you. So as we can see, the upside one is u and it is 1 plus t. So differentiate u, we get u prime equals to 1. And then v, which is the denominator part, we get e to the power of 2t. And then we differentiate the v, we get v prime equals to 2e to the power of 2t. And then we just put this whole thing sub into this equation here, the formula given here. So we get differentiation of dy dx, which is -1 minus 2t over e to the power of 2t. So we proceed with the answer here, and then we also sub in the dx dt, but we inverse it. So it becomes 1 over 2 e to the power of 2t. And then we get our second derivative, which is negative bracket 1 plus 2t over 2 e to the power of 4t. Okay, so for this question, we have to show that it's also a proving question. And so if we didn't get this answer at last, it means our working is wrong. So to show that second derivative equals to negative bracket 1 plus ln 4 over 32 when t equals to ln 2. Okay, so basically we just sub in the value of t, which is ln 2 here, into this equation. So we will get, okay, some of you might think that this is the final answer already, but we don't forget that we can see e to the power of ln here, which we can simplify again. Okay, let's look at here, the bracket here. So e to the power of 4 ln 2. As I said, ln, we can work with it with using logarithm rules. So we bring up the 4 to 2, so we get e to the power of ln 2 to the power of 4. So when we see e to the power of ln, right, we automatically know that it is 1. So we cancel out e to the power of ln, we get 2 to the power of 4, which is 16. Stop the 16 back into the equation so that we will get our final answer, which is negative bracket 1 plus ln 4 over 32. That's all from me. Thank you.
Wait. Hello everyone. Right. So we are going to revise some trigonometry differentiation. So wait a minute. Right. So these are the 6 basic trigonometry function differentiation. So we have sine x, cos x, tangent x, sec x, cosec x, and cot x. So we are going to do the differentiation of sine x. Sine x, when we differentiate it, we will get cos x, right? And cos x, we will get negative sine x, right? We have learned it in the physics chapter 9 and 10, right? So I think these two equations is no problem. So let's move to the tangent x. So for tangent x, I will tell you how I remember these 6 basic trigonometry function differentiation, right? So for tangent, we need to remember t and the x, right? So we just see the position of the character c and character x. So for the tangent x, right, the t is at the perkataan pertama, right, at the first, right? So the x will also at the first when we differentiate it, x. So when the x is at the first character, we will get second, right? Same to the chord. The t is at the third place, right? So it's at the 3. So remember ts. So the s will also become the third character. So when the s is at the third character, we will know that it is cosec. But there is a little special for tangent x and the cot x, because when we differentiate tangent x, we will get a square here. Alright, so be careful, right? And take note. Tangent x will get second square x. For the cot x, we'll add negative cosec square x. Right. So for the second and the cosec is also the same. We need to see the position of the t and the x. The x is the first character, right? X. So we differentiate it, we'll get t at the first, right? So it's tangent. So the cosec is almost the same, right? Ts. Remember, t and x is just my style, right? To remember this. So the cosec, the x at the third place, right? So remember, x at the third, t also at the third. So we'll get cot, right? So but these two also a little special a little bit because we need to copy back the sec here and the cosec here, right? So how about the negative sign? How I remember the negative sign? For me, I will remember that there's the common factor. There's a C at in front, right? C, C, C. So C, 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 C. So the sound in the C is just like in Mandarin we call it at mati die. So I think that I will try to imagine if we die, we'll get negative, right? So there's a negative sign here, right? So for sine x, we'll get cos x. So and the cos x, we'll get sine x, right? So because of the c in front, I will know that we need to put a negative sign in front of it. So we'll get negative sine x. For tangent x, t, right? T at the first, right? So we remember the x at the x is at the first, right? So we'll know the sec, right? And remember, there is the square for tangent and chord. The chord t at the third place, right? So we know that the s also at the third place. So we'll get cosec, right? X, the third, right? And remember to put the square also. Same to the second and the cosec. Second, first you just copy back the second and cosec. And then we differentiate. Second, x at the first place, right? So tangent. Cosec, chord. This is how I remember it, right? So you can write down and maybe you has also your own way to remember it. So that's how I remember these 6 differentiation of trigonometry. So let's move on to the next page. So this is the 6 basics, right? So the x we call it at angle. Actually, when we differentiate the sine x, we also need to differentiate the angle also. The angle here is x, right? When we differentiate it, we'll get 1. So actually there is a 1 here, but we can just ignore it, right? So for sine x, we'll only get cos x. Same goes to the other 5. Right. So if the x we change it to a fx with, like for example the fx is 2x x squared, right? This is the angle, right? Fx is an angle. So the angle is 2x. So when you differentiate it, we'll get 2. Differentiate x squared, we'll get 2x. So when the angle here is 2x, we need to differentiate it, right? Differentiate the angle. So for example, when here is sine 2x, we know that sine will get cos, right? Sine cos. And then we just differentiate the angle. The angle here is 2x, right? 2x. Differentiate it, 2. Right. So next, move on to the cos. When there is an angle, remember, need to differentiate the angle. Right. So for the example here, the angle is x squared, right? So I will just differentiate the cos here. I will differentiate the cos here. The cos negative sign, right? Cos sine cos sine here. But there's a c, right? So we need to put a negative sign here. And then you just got the angle here is x squared, right? So we need to differentiate it. The angle for sine is also the same, right? It's also the same for the cos x squared. So we differentiate the angle. The angle is x squared, right? So we'll get 2x. So when we differentiate cos x squared, we'll get negative 2x sine x squared. So next, So next, when we have tangent 3x, right, the angle here is 3x. So we differentiate 3x, we'll get 3. Right, tangent, the same, right? T, remember T. T at the first, right? So we'll get x at the first, right? So when you differentiate tangent 3x, we'll get secant square 3x. And then the angle, differentiate angle. Okay, so we're going to the second. Second is also the same, right? Also the same for 6 basic rule. Second, we are given that second 2x squared. When we differentiate it, second, we'll get second tangent, right? X is at the first place, so we'll get t at the first place. Second tangent. And then we differentiate the angle. The angle is 2x squared. So 2x squared will get 4x. Yeah. And then move to the coset. The coset is 5x. 5x coset. Coset will get coset, and then we put a cot here because the x is at the third place, right? So we know that t is also third place, so we'll get cot. And then we see the angle. Angle is 5x, right? We differentiate the angle, we'll get 5 here. But because there is a c here, right? C, so negative. Okay. So for the cot, the angle for the cot is 2x squared minus 5x. So I will just differentiate the cot here first. The cot we differentiate will become cosec, right? Because t is as a third, x also at the third place. So we differentiate the angle. Angle is 2x squared. Differentiate it, we'll get 4x. Negative 5x, we'll get negative 5. So since there is a c at the in front here, so we'll get a negative sign here. Okay. That's how I remember it. So let's move to the power rule of the trigonometry. So the power rule, the question of power rule is jangan keluar lah. So I will just concentrate on sine and cos. So we know that sine equal to cos. Sine angle will get cos and the differentiate angle. So when there is a sine, when there is a power at the sine here, actually this one is like sine x squared, sine xn. Also the same like this. So we can, based on the function, based on the product function, it's almost the same. We just substitute sine x into fx here, right? Almost the same, right? So same here. Power n, we bring it down, become coefficient. Sine x, we know, right? Sine will get, sorry. Sorry, wait a minute. Let me erase it. So I will repeat it again. First, we just move down the power first. The power is n, right? So we'll get n here. So we just copy back both things here with the power minus 1. So we'll get sine n minus 1. And we differentiate sine x. Sine x here, we'll get cos x, right? But if there is an angle here, sine angle power n, it's also the same. But the difference is here, right? When you differentiate sine angle, we'll get cos angle with a differentiate angle. So the difference, so we need to be careful lah. So if there is an angle here, we need to add this, the differentiate angle. For example, when there is a sine square 2x, we know that the angle is 2x. The power is 2, right? So first I will do is write down the power, become coefficient, and copy back whole thing with the power negative 1. So its power is 2, right? So in negative 1 will become sine 2 negative 1 angle. And then differentiate sine 2x. Sine 2x, we'll get cos 2x, right? And then the angle is 2x, so we'll get 2 here. So this is the answer. This is the final answer, right? After we simplify it. So let's move to the cos. Cos is almost the same, right? Just the difference is this. Cos, differentiate cos, right? And here. Cos, we'll get sine x with a negative sign here. So we differentiate cos angle, we'll get sine angle with a differentiate angle and a negative sign here. So for example, we need to differentiate cos x squared power 3. So we take down the power first. The power is 3, right? So we write down 3 and copy back cos x squared with the power 3 negative 1. And we differentiate the cos x squared. We differentiate the cos x squared, we'll get sine 2x, right? With a negative sign here. And a differentiate angle. X squared will get 2x. So after simplify it, we'll get the final answer. So since we don't have much time yet, so I will just show you the example for the other 4 trigonometry product rule. So you can just see, I will just show you, and then you can take a screenshot here. Because the product rule is seldom jarang keluar dalam PSPM, right? So you just need to know the formula. Right, you can take a screenshot. So basically, you need to focus on the 6 basic rule and the basic rule with angle. So thank you everyone.
John, sorry. Did you open your mic?
Oh yeah, sorry, it's my blunder. Sorry, it's my blunder. Thanks for reminding me. Okay, so just now, I believe that everyone has already completed your presentation, and all of them were really well. So I suppose like all of you are more to explaining the concept, and you give examples on how you should cope with a certain questions whenever you face them in the PSPM, and you can just apply the concept that you guys have explained just now, and they were really clear. And I suppose everyone is also well understood. That's why we couldn't see any question in the comment section below. Okay, so just to make sure once again, for our power leaders, do you guys have any questions to add on? Lim and Mia, do you have any questions to be
Yeah, Damia
shared
has
with
a
our
question.
audience?
Right.
So who will be sharing?
Me.
Oh, okay. So this will be the question, is it? Oh, it looks so hard, man.
John, I try buat.
Why don't you have a try?
Tak. I punya max tak boleh. I punya max tak.
John,
John,
try
try
lah.
lah. Try. John, try.
Tak, kenapa aku yang try leh?
Cuba lah, okay?
Tak
One by
boleh.
one.
John.
One by one. Okay.
Okay, tak apa.
First kena buat apa?
Kita
Try,
kena
try,
bincang sama-sama.
Okay. First buat apa?
First, asal kau yang jelaskan?
It's the denominator, right? R square. So we just multiply R square both sides. Right?
Okay. Betul-betul bawa pergi sana. And then?
And then
hilangkan log. Kan ada log E.
I think is log E.
Log di sana. Jadi E power of yr square equals to x over m minus
So have an exponent.
Times the m.
Lepas tu m.
Yeah,
M.
And we just need to simplify it.
Rearrange.
Oh,
get-
so different
oh.
resolution. Merry
you guys.
Merry
Christmas.
Christmas.
Merry
Oh,
Christmas.
oh, Merry Christmas, guys.
Oh, okay, so we have an Easter egg right here. Okay, so it's a blessing and it's a wish to all the audiences that are celebrating Christmas in days to come. Okay, so thanks for the effort from our power leaders for Science Max today. You guys did a really well job. And I'm pretty sure the way you explained were really good. That's why we couldn't see any questions down at the comment section there. But anyhow, it's okay. And also, I would like to pinpoint another thing, which is actually today is YH's birthday. So I can't sing a birthday song right away. So I wish YH happy birthday. And also I hope that our audience can just write down happy birthday YH down there. Just to wish him, okay? So we're going to leave a minute for you all to ask if you have any question.
So, I think boleh start share screen kot.
Okay. So Lim, actually just now you have a certain parts that you didn't go on really clear because you thought we are running out of time. Do you wish to proceed with them right now?
Yeah, sure.
Okay, and I can even notice you changed your name to Handsome Lim. Yeah, I know you're handsome.
I don't know who changed my name, right? So,
I know you
Wardina
changed
also.
on your own. I know you changed on your own.
So I will just
Okay,
continue
Handsome
with
Lim.
the
Okay, Handsome.
tangent part.
Yeah, you just continue with. Yeah, just now you skipped some parts because you thought we are running out of time. Or else everyone can explain together.
It's almost the same, right? The tangent power. First, we just bring down the power first. N, we'll get N, right? And then we copy back the whole thing with the power -1. And then we differentiate tangent x. The tangent x, the t is at in front, right? So the s also become in front. So x second. But tangent is a little bit special. We need to add a square here. So we final we'll get n tangent n minus x second square x. So like it's basically it's almost the same. But I think that you need to focus on the basic rule lah, because the power rule is not, it's very hard, right? So the PS/PM will, I think PS/PM will not have this such question. But maybe you can just take a screenshot because I didn't
Oh, so this.
have some example, right?
So these are the most advanced version, I suppose, because we don't really see this kind of question very often in the PSPM or even the exercises that I did on my own or the homework assigned by my lecturer.
So
Okay.
you just need to
Okay, so
remember from the right?
yeah, I just need to remember some of them. Okay, just now I went on once again with all the comments. Still, I couldn't see any questions. I think that's a good sign because maybe they understood really well. But I'll also share some comment lah, okay? Do we have Lim mesti paling power? Of course lah. Lim paling mantap. Hey, what everything is about Lim ah? Okay, from Ariana, nice Damia. Good job, Damia. Together wish YH happy birthday from Gareth. Yes, we already
Thank
wish
you,
him
thank
happy
you,
birthday.
thank you, thank you. You are loved and you are blessed.
Oh, so one of our solid fans, Easy, who has been here with us for
If you
the
notice
third
that
day,
the question, right?
you notice just now.
Yeah, the question is actually from the soalan set D, because I think the question is a bit tough. For some, I think
Mm,
a bit tough. So I tend
okay,
to
so it's set D for KMS.
yeah. Anyways, I hope you all can understand.
Yeah, I'm sure they can. That's why they don't have much question. Okay, Hong Tae. YH memang cute. Okay. Thank you, YH. So many compliments. All of them are compliments. Could you guys see it?
Yeah.
Okay, anyhow, we have 4 minutes to go. That's why I wish to spend some time on these comments, just as a compliment for our power leaders for spending so much effort on this event. Nice name. Oh, I guess this is for Lim just now because you actually renamed yourself to Handsome Lim. Okay.
Right. I was just present just now.
Okay, and of course we have a lot of wishes for YH on
Thank
your
you,
birthday.
guys. Thank you.
Sintong. Okay, Sintong is from KMS if I'm not mistaken. What does this mean? Mia is a question for you.
It's not a question. You know him, like.
I don't know him. I don't know who is Muhammad Kuyum. I don't know him. I have a question.
Tak mengaku kawan eh.
How is John so handsome? Okay, maybe you should check your eyes. Sorry lah. Hi, Suzanne. Okay, may I know if you're willing to share the notes? Okay, so 80s, if possible, can you please write down, like, if you are from KMS, I think it's possible for us to share it to you. If you're not from KMS, maybe we can find other solution to direct the notes for you. We just write down where you're from which college. I want Lim's IG. Nick. Hey, Nick was the power leader for our power.
Yeah, for bio, right?
For bio.
Okay. Okay, we have 2 more minutes. Let's wait for other questions from, also the one from Alice, because she wished to have the notes.
Maybe dia boleh contact Lim.
Okay, how to answer this question? Unpredictable. Oh, Lim, can you just write down a contact down there?
Boleh cari dekat Sky Academy punya IG.
Okay, okay, so at least you are from KMS, so I will wish to explain once again. Okay, actually, if you have IG account, you can access to our IG, which is the same name as our YouTube channel, Xcode Academy KMS. And right at our biography, you can see a link which will direct you to the name list of all the power leaders that we have over here at KMS. And you can just click into the Science Max power leaders, and you have a lot of names down there. And you can just find Lim Chin Feng, Damia, Batrisyia, Suzanne, or even YH, and you can ask the notes from them. And I wish this helps you out. Okay. Okay, so it's already 8:59. I think we should spare some time for our next session. Okay, so once again, lots of gratitudes and appreciations to our Science Max power leaders for being so informative, and also the way you present was really interesting. And as well as I wish to bid my thanks to our audience or other students from other colleges for being here with us and hear us out on our presentation. Okay, so we're gonna end our session for Science Max, and we're gonna continue with Accounting Max. So thank you, Mia. Thank you, Lim. Thank you, Suzanne. Thank you, YH. Bye.
Bye.
Thank you. Thank you. Thank you.
Okay, guys, so it's already 9 sharp. As promised, we're going to go straight into Accounting Max. But if you're a science students, you can join our Accounting Max session as well, since the thing that we're going to discuss is almost the same. Not almost the same, but they're under the same topics. Okay. Okay. So for our Science Max, we're going to have 3 power leaders. 2 of them are the heads of subjects, who are Lam and also Wardina, and they're going to be aided by Violet, who will be the assistant for today. So I'm going to have Lam here. Wardina, as well as Violet. So can you guys make a self-introduction about yourselves?
Hi, I am Lam.
I'm Wardina.
And I'm Violet.
Yeah, introduce yourself a bit and you can just go straight into your presentation.
Okay. So good evening, everyone. Thank you so much for being with us tonight for a revision session for accounting mathematics in chapter 8, differentiation. So let me share the screen first. So can you all see the PowerPoint? Can you see the PowerPoint?
No, Violet, I can't see.
Not yet.
Not yet.
Okay. Can you?
No, I not appear yet.
John, can you please admit the screen sharing?
I think I already admitted. It's not showing up yet.
No,
Is it from my side or from John's side?
eh?
Right,
Well, I think you can try again.
Let's try again.
Okay.
Okay. So again, right before we start, I would like to remind that for the explanations for the concept in this chapter, the power leaders from Science Math had just actually explained them so well for the last session. So for this session, we are going to make a roughly revision about the rules of differentiation, and we are going to focus more on PSPM questions in part B, which are the questions keep asking us to prove this, show this, and all those things. So in Dina will start we start with the rules of differentiation.
Okay, Bismillahirrahmanirrahim. My name is Wardina. You can call me Dina. Alright, in the chapter 8, we had several rules on differentiation. But if you recognize, there are few of them we already learned it in secondary school. So it's just like a recall. Okay, so we have the first one, we have the sum rule. Okay, where you can identify this sum rule. Okay, for the sum rule, you will identify it with the plus and minus symbol. So how to differentiate it? You just differentiate it each term, and with the formula u prime x plus or minus b prime x. And for the second one, we have the product rule. For product rule, how to use it? Okay, I have a tip. If you have more than one x, as example, we have 2x, and the relation of the 2x is multiply. So you can apply the product rule in here. So the formula will be ub prime plus bu prime. We need to add the plus symbol in the center. So the third one will be quotient rule, which is another tip. If you find that there is a more than one x and the relation of these two x is division, so you can apply this quotient rule by using the formula vu prime minus ub prime over v squared. And for the fourth one would be chain rule. Okay, for the chain rule, it will be used when you find that the equation is much more complex and you think that take out the equation would be easier for you. So this type of rule you can use where you let u equal to gx as example on the screen. So how to solve it, how to differentiate it, you need to differentiate it separately, which is you differentiate equation y in term of u and differentiate equation of u in term of x. So after you solve it separately, you need to combine it back. With formula, dy over dx equal to dy over du multiplied with d over dx. Actually, there's one more rule, which is the power rule. I think I forget to put in, so I just equal it. For the power rule, you need to put the power into the front, okay? And then for the power, you need to minus 1, and then differentiate if you have the bracket, so you need to differentiate in the bracket also. So actually for the fourth or fifth first rule, we already learned it in secondary school. So for next rule will be explained by Violet. Dipersilakan.
Okay, so for these rules, we actually met them in secondary school. So for next, exponent function, we actually just like newly meet them. So when there are two types of exponent function. So for the first type, when y equals to a to the power of x, so dy dx equals to a to the power of x, you just copy it and multiply by ln a. Quite simple. So for the second type, when y equals to a to the power of fx function, so dy dx equals to a to the power of x multiplied by f prime x multiplied by ln x. So this is for the exponent function. So for the second type, logarithmic function, there are two types as well. For the first type is when y equals to ln x, dy dx equals to 1 over x. And for the second type, when y equals to ln fx, dy dx equals to f prime x over fx. So I guess we expect you guys to master all of these rules of differentiation. So Lam actually selected some questions which are real hard and tricky from different state trial paper questions. So I will start with the first question. Oh, sorry.
I
You
just
need to have a look of the question first.
Alright. For this evening, in the session we will discuss 6 questions. Okay, if you can see that the Violet. Next slide. Okay, that's fine. Okay, we have a 6 question, and if you guys see, the first to the fourth question, the pattern of the question is the same, where you find that there is a first and second derivative in the equation. So basically, first to the fourth question, the method to solve it is quite similar. Just find the dy and dx, dy dx and d2y over dx square, and substitute that into the equation. But for the fifth and sixth question, this quite different, because if you see that there's a dy over dx square. So for your information, dy over dx square is not equal to second differentiation. It's not equal at all. Dy over dx square means there's a repetition of first differentiation, where it's the same concept of a multiply with a, you get the a square. Same as this question, but it's in terms of dy over dx. So this is slightly different that you need to pay attention. And if you see that all the question for this evening is all about show and proof question. So I hope you will understand it after our explanation. So for the first question, will be explained by Violet.
Yes.
Okay.
So before I start, actually, students can actually screenshot it and try to solve it now while we are explaining it. And for certain questions, we actually prepared different kinds of methods or solving steps so that you can choose which one is you will get more comfortable with. Okay, so I will start with the first question. Yes. So the first question is, if y equals to e to the power of negative x ln x, find dy dx. Show that x squared d square y over dx square minus x square y plus e to the power of negative x bracket 1 plus 2x equals to 0. So it's obvious that we have two different parts of this question. So let's start with the first half, which is find dy dx. So we can see we have two terms of x here and they are multiplication. So we can use product rule. U equals to e to the power of negative x, while v equals to 1x. So we just make a differentiation. So we will get u prime equals to negative e to the power of negative x, v prime equals to 1 over x. So according to the formula of product rule, dy dx equals to u prime v plus v prime u. So we just substitute the information we got here into the formula. So we will see negative e to the power of negative x ln x. We can't actually factorize it or anything, but actually it's quite familiar as it is equals to y. So let's substitute y into this. So actually, Madam also reminded that in this kind of proving question, it is important for us to bear in mind to sangkut balik to the information given. So please keep alert to the question. So this is for the first part of the question, find the dy dx. So we need to find the second derivatives to show this equation. So let's go to the next one. So we use the product rules as well. U equals to x to the power of negative 1, while v equals to e to the power of negative x. Just a simple differentiation. So after we get u prime, v prime, we just substitute it inside the equation, like just now how we do. So we substitute again dy dx from this equation because we don't want the y anymore. So we will get d square y over dx square equals to this answer and expand the bracket. So when we expand the bracket, this will become positive and this will become negative. So we will get d square y over dx square equals to e to the power of negative x ln x minus bracket 2x to the power of negative 1, e to the power of negative x minus bracket x to the power of negative 2 and e to the power of negative x. So now we already have the dy dx and the d square y dx square. So let's solve the second half of this question. So we just substitute all the information we have again. For this d square y dx square, substitute it inside. And for this y, we substitute this inside. So we expand the bracket and we will get this. And try to sort it out as much as we can so that we can see x square, we will get x square e to the power of negative x ln x and all this. And the tip is don't be careless. Don't simply just leave a negative everywhere, and remember to sort them nicely so that you can actually see this can be subtracted, +1, -1, +1, and then we will get a 0. So left hand side equals to 0, right hand side equals to 0. So this question is shown. Okay, so if I didn't make it clear, please don't hesitate to drop your questions in the comment section. Yeah, so this is all from me, and I will pass to Ram for the next question.
Okay, now question 2. The question 2 is given that y equals to x multiplied with e to the power of x squared. Then the question need you to find dy dx and d2y dx square. After you find the dy dx and second derivative, you need to show that d2y dx square minus 2x dy dx minus 4y equal to 0. Untuk soalan ini kan, selalunya kita buat sampai satu muka surat panjang-panjang. Pada hari ini, saya akan show 3 method to solve this. So, the first method is biasa yang kita buat panjang-panjang. Second ialah dia pendek sikit. Yang third dia paling pendek kerana kita kena alert untuk cari yang mana boleh equal to apa. Nanti saya akan show. First, saya show method pertama. Kita cari first derivative dy dx. So the equation is y equal to x e to the power x square. Dia ialah darabkan. So kita boleh guna product rule. let's u equal to x, v equal to e to the power of x square. Then kita differentiate. U prime will equal to 1, v prime will equal to 2x e to the power of x square. Yang ini e to the power of differentiate exponent, you tak faham, you boleh refer back tadi section yang sebelum ini. So we substitute back to the formula dy dx equal to u prime v plus v prime u. Then we substitute u prime v and v prime u that we get just now. We will get dy dx equal to 1 multiplied with e to the power of x squared plus 2x e to the power of x squared multiplied with x. We expand it, we will get dy dx equal to e to the power of x squared plus 2x e to 2x squared e to the power of x squared. Then the two term got the same common e to the power of x squared. We can factorize it and rewrite it with e to the power of x squared bracket 1 plus 2x squared. After we find the dy dx, we need to find the second derivative. So we find from the dy dx, let's u equal to exponent power of x squared, v equal to bracket 1 plus 2x squared. Then we differentiate u, we will get 2x e to the power of x squared. We differentiate v, we will get 4x. Then we substitute back to the formula of product rule. d2y dx squared equal to u prime v plus v prime u. We substitute back the u prime v and v prime u we will get d2y dx squared equal to 2x e to the power of x squared multiply with bracket 1 plus 2x squared and multiply with 4x e to the power of x squared. Then we expand it, we will get 2x e to the power of x squared plus 4x cubed e to the power of x squared plus 4x e to the power of x squared. Then we simplify it, we will get 6x e to the power of x squared plus 4x cubed e to the power of x squared. After we find dy dx and d2y dx squared, we go to the second task. Show that d2y dx squared minus 2x dy dx minus 4y equal to 0. That we write the dy dx and d2y dx squared we find just now. Then we left hand side is equal to d2y dx squared minus 2x dy dx minus 4y. After we rewrite it, we substitute back dy dx and d2y dx squared yang kita cari tu sub masuk, kita akan dapat 6x exponent power of x squared plus 4x cubed exponent power of x squared minus 2x bracket e to the power of x squared plus 2x squared exponent x power of x squared bracket minus 4x exponent power of x squared. Then kita expand yang 2x tu, we will get 6x e to the power of x squared plus 4x cubed e to the power of x squared minus 2x e to the power of x squared minus 4x cubed e to the power of x squared minus 4x e to the power of x squared. Then we simplify it, we will get 0. Then the right hand side is equal to 0. We can conclude that. Then left hand side is equal to right hand side. We can conclude that we show that the equation is right. Now I will show the second method. The second method, I will start from dy dx. The dy dx is exponent x squared plus 2x e to the power x squared. Then we can factorize it. We will get exponent x squared bracket 1 plus 2x squared. Just now I show from the previous slide. So from here, d2y dx squared equal to 2x. For this equation, we also can factorize if you want to know it get from where, you can refer to the previous slide. Then d2y dx squared equal to 2x multiply with e to the power x squared bracket 1 plus 2x squared plus 4x e to the power x squared. Then the e to the power x squared bracket 1 plus 2x square is same with the dy dx. So we can straight away we can terus dy dx masuk ke dalam equation tu, then we will get d2y dx square equal to 2x dy dx plus 4x e to the power of x square. Sama dengan tadi, after kita dapat d2y dx square, kita let left hand side is equal to d2y dx square minus 2x dy dx minus 4y. Then we substitute back the d2y dx square, we find is 2x dy dx minus 4x e to the power x square minus 2x dy dx. Yang ini dy dx kita tak payah substitute e to the power x square plus 2x square e to the power of x square. Kerana depan dalam d2y dx square kita ada 2x dy dx. Nanti kita boleh simplify dengan dia. So we simplify it, we will get 0. Then right hand side is equal to 0. In conclusion, we can get left hand side is equal to right hand side. Kita dapat show the third method. Third method is paling senang. Tapi kamu kena pandai untuk twist dia punya equation. So y equal to x e to the power x square, dia guna product rule. Yang ini tadi sudah show. We will get dy dx u prime v plus v prime u.
Sorry, I think I have to skip a slide.
Wait.
Sorry.
Yang ni baru method ketiga. Y equal to x e to the power x square. Then dy dx yang dy dx tu ialah kami yang tadi cari. Atau kita differentiate dengan product rule. We will get dy dx equal to e to the power x square plus 2x square e to the power x square. Then for the second term, we factorize the 2x. Kita tulis macam ni. 2x multiply dengan x e to the power of x square. Then you determine x e to the power of x square is same with y, right? So we substitute y inside the equation. We will get dy dx equal to e to the power x square plus 2xy. Then the 2xy, then we now we can find the second derivative d2y dx square. For the exponent term, you can straight away differentiate. For the 2xy, you can use product rule to differentiate it. U equal to 2x, v equal to 2y. For this, I didn't show because it's very simple. So d2y dx square equal to 2x e to the power x square plus 2x dy dx plus 2y. For when we differentiate it, then you determine x e to the power x square dia sama dengan y kan, so dia terus you boleh terus tulis 2y plus 2x square 2y plus 2x dy dx plus 2y. Then we tambah semua, susun baik-baik, kita akan dapat d2y dx square equal to 4y plus 2x dy dx. Then the question is given by equal to 0. So we can move all the term at right hand side to left hand side. The positive will become negative. So we will get d2y dx square minus 2x dy dx minus 4y is equal to 0. For this equation, that is same with the question given. So we shown that we have shown. So for this method is more easier than method 1 and method 2. Okay.
But you have to really keep alert of how to factorize this out, or else you can't really see it.
Yes. If you don't know how to factorize, you can't use this type of this method because it's more I don't know
Advanced.
yeah. So let's proceed to the third question. The third question is given that bracket x squared plus 1 multiplied with y is equal to e to the power of x negative x. Then prove that bracket x squared plus 1 dy dx plus bracket x plus 1 square y is equal to 0. For this equation, same with just now, I will show you three methods. For now, I am showing first method. First method, we determine that what type of differentiation rule of differentiation we need to use. For this question, you can use change quotient rule or product rule. But for me, I will use product rule because product rule is more easier. Change quotient rule is more complicated. For this product rule, we let u equal to bracket x squared plus 1, v equal to y. Then we differentiate u, we will get u prime equal to 2x, v prime equal to dy dx. Then we differentiate the whole equation with same we did before. Dx 2x multiplied with y is we get from u prime v and plus bracket x squared plus 1 dy dx we get from v prime u. So is equal to differentiate of exponent is we will get negative e to the power of negative x. Then we move the 2xy to the right hand side. We will get bracket x squared plus 1 dy dx equal to negative exponent power of negative x minus 2xy. Then dy dx we will get we move the x squared plus 1 to the right hand side. We will be from multiply will become dy. So dy dx is equal to negative exponent minus x power of minus x minus 2xy is over bracket x squared plus 1. So after we find the dy dx, we can proceed to the next. We prove that bracket x squared plus 1 dy dx plus bracket x plus 1 square y is equal to 0. Then left hand side is equal to bracket x squared plus 1 dy dx plus bracket x plus 1 square y. Then we substitute dy dx inside the equation. We will get and then the y we can let y is equal in term of x. So we can get y is equal to exponent power of negative x over x squared plus 1. After we get these two equations, we substitute inside the left hand side. We will get x squared plus 1 multiply with negative exponent power of negative x minus 2xy over x squared plus 1 plus bracket x plus 1 square multiply with exponent negative x over x squared plus 1 bracket. So we can simplify the first term. We will get negative e to the power of negative x minus 2xy is, then we expand the second term, bracket x plus 1 square. When we expand it and then we multiply with exponent power of negative x, we will get x square e to the power of negative x plus 2x e to the power of negative x plus e to the power of negative x over x square plus 1. Then kita boleh substitute y. Kita nampak y dalam equation kita kan. So kita boleh substitute y inside the equation. We will get then kita boleh jadikan dia same denominator in order we can cancel with the second term. So the negative exponent power of negative x kita juga kena darab dengan x square plus 1 over x square plus 1. So we will get negative x square plus x square exponent negative x minus x exponent negative x minus 2x exponent negative x over x square plus 1. Tambah dengan x square exponent negative x plus 2x exponent negative x plus exponent negative x over x square plus 1. Then we can cancel off all the term at numerator. We will get 0 over x square plus 1. Any number is over 0, 0 over any number, we will get 0. Then right hand side is equal to 0. We can conclude that left hand side is equal to right hand side. We have proof. So I will proceed to the second method. The second method is we start from the left hand side. Equal to x squared plus 1 dy dx plus bracket x squared x plus 1 square y. Then we substitute back dy dx inside the equation. X squared plus 1 multiply with negative e to the power of negative x minus 2xy over x squared plus 1 plus, for now we expand the x plus 1 square. So we will get y multiplied with x bracket x squared plus 2x plus 1. Then we expand the y and simplify the first term. We will get negative exponent negative x minus 2xy plus x squared y plus 2xy plus y. Then we can cancel off the negative xy and positive 2xy. Then we will get negative exponent power of negative x plus x squared y plus y. After that, we can find the exponent. We can let exponent is in terms of x and y. So here, exponent is in terms of x and y. For this, we can expand multiply the y inside the bracket. We will get exponent power of negative x is equal to x squared y plus y. Then we sub balik exponent power of negative x inside the solution. We will get negative bracket x squared y plus y plus x squared y plus y. Then we can cancel off all the term. We will get 0. Then we can conclude that left hand side is equal to right hand side. If proved. Now I proceed to the third method.
Sorry for interrupting, but the difference among these two methods is like here, we didn't substitute the y, but we just carry forward and then until we have to move pindani to get the e to the power of negative x to get this equation. You have to keep alert as well to use this method.
Yes. So the third method is more easier than second method and first method because the third method for we explain is we use the term, we change the term like exponent power of negative x is in term of what, or y is in term of what. We alert with changing this type of term. So we start from differentiate, and then we after we differentiate, we will get bracket x squared plus 1 multiply with dy dx equal to negative bracket x squared plus 1 multiply with y minus 2xy. This we showed before. Then next, here for the right hand side, we can factorize negative y because the the common term. So when we factorize the negative y, we will get negative y bracket x squared plus 2x plus 1. Then we can be factorized for x squared plus 2x plus 1 for the the PowerPoint is something for ada salah sedikit lah, dia bukan sampai negative y, dia factorize dalam bracket saja. For this, you can use your calculator to find the roots. When you use the calculator to find the roots, we will get x equal to negative 1. When you get the one term for one root for from your calculator, it means that the root is same for two roots. So we can conclude that we can write it as bracket x plus 1 square. So the last is when we write at this, we'll get bracket x square plus 1 dy dx is equal to negative y bracket x plus 1 square. After that, we move the right hand side to the left hand side. It will become bracket x square plus 1 divided dx plus y bracket x plus 1 square is equal to 0. The last solution that we get is same with the question given, proof. So we have proof. For question 2 and question 3, if you got any question, you can ask at the comment. Now I will pass to Dina to proceed to the next question. Thank you.
Okay. Thank you, Lam and Violet, for the explanation. Okay, starting from this question 4, I will just give explanation briefly because I'm sure that you guys can go through detail after Lam and Violet has explained it. I hope. Okay, for the question 4, also ask us to show the question given. So in this question 4 also has the 3 method, and bear in mind we will the all the 3 method has the same solution until we find the first differentiation. So we will show it for the first method only. So the second and third method you can relate to the first method. Okay, we will start with find the first differentiation. For this question, we need to find until the second differentiation because as the question given, there's a d2y over dx square, so we need to differentiate it twice. So for the first equation, we will use the product rule because we see there is a x and x, so the relation of the two x is multiply, so we apply the product rule. So to make it easier, you can take out what u and find the u prime, v and the v prime and just put it into the formula. So you will get e the power of x plus 1. Next. Okay, I will just go roughly. E the power, because you get the next. Okay, and then you see the yellow box there, and then just similar to the equation. So to make your solution shorter, you can substitute that as the y. Okay, to make you more something like maybe will continue kalau longer solution will make you panic. So you can substitute as y or just leave it as like that. Okay, and then we will find the second differentiation for the method 1. You see that there's a quotient rule there because there is x at the top and the bottom, and the relation of x is division. So you can apply the quotient rule there. So you find the u prime, v prime, and just put it into the formula. And then as you guys see in the formula, I didn't put the y term because I assume that you want to stay as at the yellow box. Okay, it's another method. Okay. Alright, and then you get this final answer of d2y over dx square as e the power of x plus 1 ln 3x plus 2. You can just skip that. Okay, next and next. Okay, so we will start to show the equation. Okay, we have already the first and second derivative. So for this first method, we just sub it into the equation where for the left hand side, we start with the left hand side where kx plus 2 multiplied with the second derivative. So just substitute the second derivative that we already solved and put it in the bracket. Don't forget to put in the bracket because the bracket also mean the multiply. So you don't be careless if you put in the bracket because we need to expand it after this. And then that's for left hand side. And for the right hand side, also we need to substitute, but this time with the first differentiation because it's only show dy over dx. So substitute the equation that we already solved and put it in the bracket. And also there's a y for the last term, right? So we just substitute the y that had already given in the equation. So we see the final answer for left hand side and right hand side is equal. So we can show that we can conclude that left hand side equal to right hand side. So the question is proven. Okay. For the second method, okay, once again I recall for the second and third method, we will start with the first differentiation where we already find the dy over dx equal to y plus 3 e the power of x plus 1 over 3x plus 2. This time we will substitute the first term with y. Okay. For this type of equation, same, we have the x and x for the fraction, so we can use the quotient rule. Just put out the u prime, v prime, and put it into the formula, and you'll get like on the screen. Okay, I think this is the most simple equation that we can get for the second derivative. Okay, and then we move on to the showing the equation. So let's start with the left hand side. For left hand side, we can substitute that, but this time with in term of dy over dx. So just sub in the equation, and then until the third step, you will get in the bracket of 3 e to the power s plus 1 over 3s plus 2. This is quite familiar, right? So let's look back at the first derivative. There's a dy over dx equal to y and so forth. So we can change it into the ambil dia main, dia punya tu ambil main dia yang fraction yang ada exponent, and then let y move to the left side. Okay, and then you can change it in the bracket with dy over dx minus y. Okay, so for the next step will be you can expand the 3 into the bracket, and then if you see that there is a dy over dx and dy over dx, so there's a common factor there, so you can factorize it with the same dy dx. So it can be 3s plus 2 minus 3 dy over dx plus 3 e to the power of s plus 1 s plus 1 plus 3y, and then you can simplify it, become 3s minus 1 and so forth. So we're showing that left hand side equal to right hand side. So for the second method is shown. Okay, next we go for the last method for the question 4. For this time, we will make it start with the sparse differentiation. Okay, for this method, we will start once again, we start with the first differentiation, and this time we will make it as a product rule. Okay, how to make it as a product rule? Okay, we can change the fraction into the product rule with multiply 3x plus 2. How we know what to apply with? First, we need to look at the fraction and look for the denominator. Denominator is 3x plus 2, so we need to multiply with 3x plus 2, and then multiply with each term in the equation, and you get the 3x plus 2 dy dx for the left side and the right side, as you can see on the screen. And then for the next step, you will be differentiate, because in the equation there is a second differentiation, so you need to differentiate once again. So for the left hand side, we can apply the product rule. Okay, and then also the implicit differentiation in here. So bear in mind, you need to recall what implicit differentiation is. Okay, so if you are unsure about the implicit differentiation, you can leave a comment there. Okay, and then for the right hand side also we have the product rule, and then there is the exponent. You can refer to what Violet had explained before, so you can apply it into this equation. And then after we sub in, after we differentiate, we need to move the 3 dy dx into the left, into the right, because the equation given only has the second differentiation on the left side. So anything that not related to second differentiation, just move to the right side. So we see that there is a common term for dy dx, and then we can factorize it as a 3x plus 2 minus 3, and then simplify it, become 3x minus 1 dy dx plus 3y and so forth. So the equation is same as the answer is same as the equation, so it's shown for the fourth question. Okay, all right. For the fifth question, we have here the quite different. Okay, let's see the question. Okay, given the function is x squared plus 3xy plus 2y squared equal to 10, and the question asks to show the equation, and there is the dy over dx squared. Okay, bear in mind, dy over dx squared is not the same as second derivative. It's not equal. It's the different meaning. So you cannot use the article, use the different method or different solution to solve this kind of question. Okay, to make it easier, the first step, if you find this type of question, just take out the equation given, which is x squared plus 3xy plus 2y squared equal to 10. So we need to find the first differentiation first. Okay, for this type of equation, also implicit differentiation because we recognize there is x and y in the same equation. And then the x squared, you become 2x, and then 3xy, there is a x and y there. So you can use the product rule too. You become 3x divided over dx plus 3y plus 4y divided over dx. If you think it's quite difficult, you can take out one by one. U is what, U prime, V, and V prime. So you can see it very well. Okay. For next step, because the equation has the second differentiation, you need to differentiate once again. So for my tips, I think better you put in the bracket after you differentiate once again, because maybe in your examination we have extra time, can, so we can recheck our answer if it's correct or not. Okay. After that, once again, in the bracket, you will see there is a dy over dx multiply dy over dx. There's a repetition of first differentiation, right? So if you think it's quite difficult, you can also take out u equal to y prime, v, and v prime. Okay. So after that, we will simplify it. How to simplify it? To simplify it, you need to rearrange or organize the term. With first, you need to utamakan yang ada second differentiation, which is d2y over dx square, and then you need to have the first differentiation dy over dx, and if you have the constant, you can put the constant. Okay, for this equation, there's a common term, which is second differentiation. So you can factorize 3x plus 4y, and then you get dx plus y multiplied with second derivative. And for the dy over dx, because it's the repetition, you can write you can write as power of 2, and then plus 6 dy over dx plus 2, and then the final answer is same as the question given. So the question 5 is solved or shown. Okay, I hope I not go too fast. Okay, I hope you can get to it. Okay, for the last question for this evening. Okay, for this evening, we have given that y minus 1y equal to x squared plus 5e the power of x. And also, this last question, we also have dy over dx squared. Bear in mind, if you have dy over dx squared, it's suitable for you not to use the previous method where you find each dy dx, d2y over dx square, and submit into the equation. I think it's not suitable because it might challenge you. Okay, so we will start with the first step where you take out the equation given, which is y equal to ln y equal to x squared and so forth, and then we do the first differentiation where you can apply the implicit differentiation here because there is x and y in the same equation, and then you differentiate y, become dy over dx minus 1 over y dy over dx. Why it become 1 over y? Because ln is basically the log of e, base e. So when you find log, it automatically 1 over what? 1 over y, and then once again you need to differentiate what is in the denominator, which is dy over dx. Apply the implicit differentiation, and then for the right hand side, if we differentiate x squared become 2x using the power rule, and then plus with 5e the power of x using the exponential rule, I think. Okay, for the third step, we factorize it because there is a common factor there, which is dy over dx. So we can factorize it for the left hand side. For the right hand side, just leave it like that. For the fourth step, we need to differentiate once again, right? Because the equation in the question given, there is a second derivative. So there's a hint, we need to differentiate once again. So Okay, and then we can apply the product rule too. And then for the left hand side, it become 1 negative 1 over y, second derivative plus 1 y over 2 y square divided over the x square equal to 2 plus 5 in the power of x. If you see that, why there is a dy over the x square? Because there is a repetition. Okay, once again, because there is a repetition of first differentiation. Okay, if you find it's difficult like this step, because it's too simple for you, I think you can take out once again u equal to what? Find the u prime, v and the v prime. So last step will be susun, organize or rearrange the term. So we will start with the first, the second differentiation, which is 1 minus 1 over y multiplied with second derivative plus 1 over y square multiplied with dy dx square. And for the right hand side, just leave it like that, 2 plus 5 in the power of x. So the equation, the answer is same as the equation given. So the question is shown. Okay, I think you guys, I hope like korang boleh catch up apa yang I boleh conclude sebelum kita masuk kepada Q&A session. I think untuk soalan dalam chapter 8 ni, korang kena know the basic rule for this chapter. Like as I told before for the second slide there, kita ada banyak rule. Korang kena pastikan korang tahu rule tu, and then apa-apa je question diberi, insyaAllah korang boleh apply, because when you have the basic, you can manipulate the question. You can be creative on our paper examination. So I think that's it. We can move to Q&A session.
And when you start to do the differentiation, you can determine the equation given by the question first. If that can simplify or not. If cannot, then you can straight to proceed differentiation. It can simplify or make it more easier. You can do it first, then we proceed to differentiate. It will more help you and not complicated when you solve the equation. Solve the question. That's all.
I think that's all for our presentation.
Thank you.
Yeah.
That's all for our presentation.
Okay, thank you so much for all the presentation just now. You guys were like explaining non-stop and everything was so clear. But right now we actually have a few questions over here, but I'm going to start with this one.
I didn't tak perasan jadi, sorry. Okay.
Boleh?
Okay, sekarang boleh.
Sekarang boleh.
Next question.
John there?
Hey, John.
John, Wi-Fi is not working.
John lost.
Okay, so maybe next time. So actually he asked us to explain in both English and Malay. So that means basically afterwards, for all the questions later, can we explain in both Malay and English? Okay.
Yes.
So
Okay.
kalau Pali
Let me
dia
answer this. Okay. Okay. Untuk this question, bahasa Melayu. Okay. How to define when to use power rule and when to use quotient rule. Okay, maksud dia bila nak guna power rule and bila nak guna quotient rule. Okay, tadi dah terang, maybe korang miss. Untuk power rule, korang kena guna bila ada more than 1x and the relation hubungan antara 2x tu adalah darab. So, korang kena guna power rule. Kalau ada simbol darab ataupun hubungan antara dua tu adalah darab. Untuk quotient rule, kita akan guna apabila ada 2x ataupun lebih dan hubungan antara 2x tu adalah bahagi. Kemudian kita akan guna quotient rule ni untuk solve the question. Okay, I hope that will answer the question of Khairisa. Thank you for asking the question.
Tapi masa tapi masa dia soalan dia bagi fraction kan, y equals to u bracket X over V bracket X. Yang ni jika kamu nak buat you tak nak guna quotient rule, you can make it as product rule. Yang part bawah we will get show is like y equals to u bracket x multiply with v bracket x bracket -1. Then we can use product rule to solve the question, because quotient rule for someone is more complicated and susah sikit untuk jawab, susah sikit takut salah letak jika kamu nak senang, atau sometimes for example y equal to 3x square plus 1 kita over x. For this kita boleh guna quotient rule, tapi kita juga boleh guna product rule. I try to explain in product rule lah. Kita boleh separate function tu jadi y equal to 3x square over x uh, 3x square over x plus 1 over x.
Sorry.
Product rule okay juga sebab dia ada buat naik atas jadi negatif.
Yang ni pun boleh, yang tadi saya sebut tu pun boleh. Then jika guna yang saya sebut tu, we will get y is equal to 3x plus x minus x power -1. Then we can continue with the product rule differentiation. There is some rule, not product rule. Sorry.
Okay. Another question?
Okay, next question. How come negative e to the power of negative x multiplied with ln bracket x equals to negative y?
What's number question is this? You can check the question. Which question is this? I think long question. I think lah long question. Yeah, long question. Yang ada negative y.
Negative y.
Negative y will say.
Wait.
Where is it? I think the question. Third question, I think.
I'm not sure which method is he mentioning.
Where is it?
Third question.
I can't see it.
I also can't find it.
Negative. I think.
You cannot find
So
it.
basically, is there a typo?
Yeah, I'm so sorry. We can't.
You can find it.
I know. It's
I can't find it.
It's the first question.
First question, in part.
Oh, it's the first question.
Oh, first question. So you want to share the screen or not?
Yeah, but the question is given. Y equals to e to the power of negative x ln x. Actually.
Oh, how it come? Oh, okay.
Yeah. So
Because, you want to share the screen or not? Okay.
yeah. So you really have to keep alert of what has given in the question, so that you just can keep stitching everything.
Yeah, you can find it from the equation given by the question.
Yes. And also, maybe the person asked why there's a negative in front of y. Maybe it's the equation. Kita nampak kat depan tu ada negatif, so that's why kita kata negatif. Tapi y tu still sama dalam equation. Maybe there's a question, maybe. Okay.
You kena pandai dalam cari yang term ini dia ada sama dengan term lain tak. Jika sama, you tengok dia boleh substitute masuk tak. Jika dia substitute masuk, buat lagi kamu jadikan kamu lagi senang untuk solve, you can proceed to solve. If you think that when you sub it inside and then more complicated, depends on you lah. You need to continue or not. It depends on you lah. Tak mungkin saya cakap tak boleh kan.
Okay.
Not suggested lah. Okay, next.
But
Ada.
how to get more alert? I think for me the only way is just to do more practice.
Yeah, do more practice.
Next question.
Okay, where is John?
John, are you there? John.
Hello, John.
So what else commented?
I think there's a Siti Nashahira question at 9:28 p.m. You can see that there's a memang kalau differentiate y akan jadi dy over dx. Yeah. You see that question? Yang question
Okay.
Siti Nashahira dekat di comment on 9:28 p.m. Okay. Okay, I will explain it. Okay, kita akan tengok contoh equation tu kepala main dia adalah y equal to 2x plus 3 contoh. Okay, so kalau dalam dia punya sebutan dia adalah dalam x, so dia akan jadi dy over dx. Kita tengok term yang dalam equation tu. Tapi kalau soalan tu contoh kepala dia y, tapi dalam dia u. Contoh macam cerul tadi, dalam dia sebutan u, so dia akan jadi dy over du. Maksudnya dy atas tu adalah kepala dia, bawah dia tu sebutan dalam equation tu. So it become dy over du if the term in the equation is u. Yeah. I hope this answer the question. Where is John? John?
Another one? Any other question? Dina comel nampak.
John lost connecting.
I think so.
So we continue.
Yeah.
If we choose ourselves lah.
Yeah, sorry.
Question.
Until which question?
No. I
I lost my connection. Until which
We
question?
already answered another question.
So which was the question?
The question Nur Shahira. Okay,
Why we differentiate y will get dy dx, but differentiate x will only get 1. When we differentiate y in term of x, we will get dy dx. When we differentiate x in term of x, we will get dx over dx, and then is equal to 1. So we differentiate x is equal to 1.
Yes.
We differentiate y is in term of x, we will get dy dx. So you can determine this perbezaan inilah.
Okay. Apa jawapan juga. Okay. Kenapa kalau kita differentiate x akan jadi 1? Okay. Kan kita tahu kalau x saja kuasa adalah 1. Kan kita guna power rule. Kalau power rule kita akan bawa pergi depan kuasa jadi 1 terhadap x. And then kuasa je kita akan terangkan 1 kan. So 1 terhadap 1 kosong. Every apa-apa je yang sebutan kuasa kosong automatically akan jadi 1. So that's why apabila kita differentiate x, the only x will become 1.
Yay.
My kids can just explain this so well. Oh my god, I'm so proud of them.
Okay, another question. Bismillah.
John is really late, I guess.
Hard questions now. PSPM this hard.
This we cannot answer.
Yeah, but most of the questions are we got them from the trial paper from different states. Yes. So let's wish it's not as hard.
From different state.
Thank you, Wardina and Violet. Okay.
Welcome.
Thank you too. Thank you for supporting.
Yes, thank you for supporting us.
Oh,
Thank you.
we have a fan of Lam over here.
He is my classmate.
Mafo.
My classmate.
My ex-classmate. Okay, guys, share. Well done, guys. Thank you.
John, no. John, skip. Thank you. Let's go, John.
Adventure girl. Yeah. for JPP.
Is that Avenger girl?
Who study
you
in
for the
KMS
sharing.
will know.
Yeah.
Thank you for the sharing. Welcome. Welcome Syuhada. Oh, sorry.
This one again.
So
Okay, maybe.
thanks, I just realized that no, we are not. No, we actually discussed many times for all these questions as well.
Oh, our madam, our madam comment
Yeah,
on that.
madam, comment.
Madam. Thank you, madam.
Thank you, madam.
Thank you, madam.
So we wish this session help everyone to refresh or rewind back all the rules of differentiation or what to keep in mind when we solve the tricky questions about how to prove or how to prove or how to show the equation.
Yes. Thank you, madam.
Thank you, madam, for teaching us.
Yes. Last minute discussion just now.
Okay, so is this your madam?
Yes, our madam.
Yes, our madam.
Also help for
Okay,
the
so
mathematics.
let's see.
My classmate, Pak Isaikal. Thank you.
Next question.
John always playing
John
hide and
left
seek.
again.
Coco Espresso. I think we'll be in part B, right? If I'm not mistaken.
Yes.
Question 5 or 6. I'm not sure. In part B.
So-
Part A and part B will got chapter 8 question from chapter 8
But for the showing part that we share tonight, it will be
in part B.
Part B, show question. So, what we do?
Where is John?
John, help us. John.
Shall we?
Oh, John.
And
I think we need to.
Yeah. So I think that's all for today. So thank you, everyone.
Thank you, guys.
Please,
Thank you,
for those
everyone.
still online, please fill in
Okay,
the.
I think there's a problem with Wi-Fi.
Okay.
Okay,
So
that's
I'll wrap this up. So for those who are still online, and please help us to fill in the Google form and let us know what's your feedback so that we can keep improving. So I think that's all for tonight. Thank you so much. Bye bye. Good luck and all the best.
studio, right?
And oh, I'm so sorry. Accounting mathematics. We don't learn about figures. But we will have Lin or YH to answer your question.
Bye bye.